All right, y'all. We are looking right now at the beginning of the topic 12 notes. I'm going to tell you right now ahead of time that I'm using a different microphone system. I got a new pair of headphones. I want to see if this will work. So hopefully the audio isn't too bad messed up. All right. So we're going to start off actually running through a little exercise that you probably haven't seen much of since algebra. Okay. We're going to multiply these two polynomials right here together. We're going to multiply those two things together. Okay. So the way that I learned it back in the day was with FOIL. It's a little abbreviation. FOIL stands for first, outer, inner, last. Okay, and so that means when you're multiplying two binomials, you do first times first, so x times x is x squared, and then you do the outer, so x times 3. You see the x and the 3 are on the outside. Then you do inner times inner, which is 3 times x again. And then last times last is 3 times 3. So that's 9. Okay, and we add all that up and we get that x plus 3 times x plus 3. So that is x squared plus 6x plus 9. Okay, that's how I learned it back in the day. This is a skill. Multiplying a binomial like this is something that we're going to need to know how to do today for some of the problems that we're working on. All right, so we're going to start off, before we get into any of the problems, we're talking about circle theorems in this section. We're going to start off with a whole slew of vocabulary words, kind of like in the last unit. Okay, first thing we need to define is the radius of a circle. This is one that we already know. The radius is the distance from the center to the circle. Okay, so from that point in the middle of the thing, right in the middle of a circle, to a point that is actually on the circle, that is the radius. Our next definition is a chord. That is a line segment whose endpoints are on the circle. Okay? So when you look at this picture that's on your page right there, this purple line right across here going across the bottom, that is a chord. Okay, that right there is a chord. It is a line segment, and it's got a starting point and an ending point that are both on the circle itself. Okay, up next is a diameter. And diameter is one that we can identify pretty quickly on the picture. Okay, it's this line segment that goes right through the middle of the circle. Okay, it is a chord that passes through the center. Okay, it is so that's something that we've talked about chords and we've talked about diameters, but we never actually made that specific connection before. A diameter is a chord. It is just one that happens to go right through the middle. And we also know this relationship. The length of diameter is twice as much as the length of the radius. Okay, it is 2 times the length of the radius. Up next, a secant. Secant is how you would describe a line that intersects a circle in 2 points. Okay, so really what you could say is that a chord, this right here, is part of a secant line. That would be this green one right up here. That is a secant line. Okay, it's like a chord except it extends out past the edges of the circle. Okay, next, a tangent line. That is a line that intersects a circle at exactly 1 point. Okay, so when we look down here, this blue line going across the bottom, that is a tangent line. And this point where it crosses, that is what is called the point of tangency. It is the point where the tangent line touches the circle. So that pink little point right there is the line of tangency. That would make this blue line right here the tangent line. All right, so we're going to be using these definitions, little bits and pieces of them, all throughout the entirety of Unit 12, Topic 12. We're going to look at a whole bunch of different theorems that use different things of these, and they relate. It's mostly going to be relating line segment lengths and how we can set them up and use theorems that we already know about, stuff that we've already learned about geometry and stuff we've already learned about triangles. Here's our first theorem today, and you'll see how it relates to triangles as we get to the practice problems. Okay? A line is tangent to a circle if and only if the line is perpendicular to the radius drawn to the point of tangency. Okay, you need to think about in normal, regular, everyday words, no math terms, let's think about what this means. Okay? Instead of using a big fancy sentence like that. Okay? In normal, everyday terms, this is saying if you have a circle and a tangent line is right next to it, okay, that tangent line touches the circle at exactly one point right there. Okay? So line BC is tangent to circle A, and that is saying that that is the case. What that means is if it is tangent, that means it makes a right angle with that radius AB. Okay, it makes right angles. It is perpendicular. That's what that means. It means it makes right angles. Okay, so that's what is going on right there, and we're going to talk about what it looks like in some specific practice problems. Okay, take a look at this one right here. This example it gives us tells us that line segment GH is tangent to circle K. So the first question, what is the measure of angle G? Okay, we need to think for a second about what it means using that theorem, keeping that theorem in mind. If GH is tangent to this circle, that means two things. Number one, H is the only place that this line, this GH, actually touches the circle. And what that also means is that it makes a right angle with this radius. Okay, and since that is a right angle, that means what we have right here, I'll highlight it. What that means for us is that this triangle, GHK, is a right triangle. That is a right triangle. Okay? So the first question turns out to be pretty simple when you put it that way. Because we know that every single triangle always adds up to 180 degrees. When you add up the three angles inside of a triangle, it always equals 180. Well, we know now that this one is 90. This one down here was already labeled as 68. So all we have to do is know that this missing one, the angle G over there, it's just 90 plus 68 plus that missing angle equals 180 degrees. So if you just subtract 158, that gives us our missing angle right there. Our missing angle, 22 degrees. Okay, you've got several Canvas questions under our day one assignment that are just like that. All right. The next thing is this. What is the length of the radius? Now this right here gets a little bit trickier. So what I've done is off to the side, up over here on the top right, we have a drawing of that triangle, the exact same triangle, but we took the circle out of the equation, out of the picture. Okay, we just redrew the triangle. So you can see it's a right triangle up here. You've got one leg, the length is 12. You've got another leg, the length is R. Okay, that's the length of the radius of this circle. That's actually what we're going to be looking for here. Now let's talk about the hypotenuse. Okay, the hypotenuse here, you can see it over here on the label of this picture. The hypotenuse is split into two pieces. Okay, right over here, you've got a piece of it that's 9 from G to the circle. That length is 9. Okay, but you need to keep in mind that that is not the length of the entire hypotenuse altogether. Okay, you need to realize and think critically about that for a second and take note that it would not make any sense if this leg of the triangle was 12, but the hypotenuse was only 9. Okay, that is not something that would make sense because the hypotenuse has to be longer than the legs. So here's what we have. Okay, this piece of it going from G to the circle is 9. The other piece of it from the circle to the center over here is R. That's the radius. Okay, that's the definition that we just wrote down for the radius, the distance from the edge of the circle to the center. Okay, so what that means is that this whole entire piece, the whole hypotenuse altogether, is 9 plus R. Okay, so now we've got our three sides, and we can figure out what R is based on our old friend, the Pythagorean theorem. A squared plus B squared equals C squared. Okay, so that's what we're going to do. we're going to take the two legs of the triangle, r squared plus 12 squared, and say that that is equal to the hypotenuse, 9 plus r squared. Okay, here's where we're going to use those skills that we were just looking at a second ago, back on that title page at the beginning. Okay, we are not multiplying, we are not just going to square 9 and r. Okay, without fail, every time I've seen a problem like this in my entire teaching career, somebody looks at this and says that that is equal to 81 plus r squared. And that is not how it works, y'all. You have to recognize, you have to notice that this is 9 plus r times 9 plus r. This is something that you have to FOIL. Okay, this is something that you have to distribute into both of those parentheses right there. Okay, it's not going to be 81 plus r squared. It's 81 plus 9r plus 9r plus r squared. Okay, you have to recognize that. So we combine all of our like terms, we simplify some stuff, and what we have is r squared plus 144 on the left. We got 81 plus 18r plus r squared on the right. You know what's really convenient about this equation? You already have r squared on both sides of it. Okay? R squared, if you are adding positive r squared on both sides, well, r squared equals r squared, right? Like, no matter what, that's always going to be equal. So you can just drop it out of there. Okay? Those two things, they cancel each other out. We don't need r squared as part of this problem anymore. And isn't this equation, 144 equals 81 plus 18r, a lot easier to deal with than anything with r squared? Okay? All we got to do now is get this r by itself. So first we send home the friends. We subtract 81. We subtract 81, gives us 63 equals 18r. And then we send home the family members. Remember, R is throwing a party. He's got friends and family members. We send home the family at the end of the party, and it gives us that R equals 3.5. Okay, that's our radius. R equals 3.5. Okay, all of your Canvas problems for the day one practice are going to be just like these two things. Okay, if you have questions, please, oh please, just let me know, and we'll figure it out, all right? That's all we've got for the notes today. We're going to continue in the first section of the notes on our next lesson. Thank you very much.